Hello everyone. I am obviously not here today, but I did prepare some things for you to do. We're going to focus more on domain and range today. So what you need is, you should have already received this. So if you haven't yet, then please go up to, I think it's Miss Frank's, and grab this. You need 2 sticky notes. You need this page that has more examples. So there's ordered pairs and then there's graphs on the back. And then your homework is going to be, it should have been paper clipped together, but it's this functions worksheet. So this is what you are turning in for homework. I also am going to check to make sure that you are taking good notes over the video, from the video. So I'm going to check that for this page for a homework score as well. So we're just going to use this for more examples. So we're not going to do all these problems, we're going to jump around. So just to review, if we're given a relation, we've talked about how to tell if it's a function, and it's going to be a function if each input has exactly 1 output. So let's look at number 1. If I look at my various inputs, I see that -9 is listed twice, and it's going to 2 different outputs. So this is not a function. The input has 2 different outputs. Make sure you are using that exact terminology, and the 2 outputs are 6 and -2. The domain, we can still tell what the domain is. It is the set of all of the x values. So we should list them from least to greatest. So we have -4, 9, -9, 8, and 9. So the smallest one is -9. Then we have -4. Then we have 8. And then we have 9. We do not need to list the 9 twice, even though it's listed twice in our ordered pairs. We only need to list it once for the domain. The range, 6, -7, -3, -2, and 1. So similarly, least to greatest, -7, -3, -2, 1, and 6. And you close it with squiggly brackets. Let's look at 2. The domain is going to be the x values again, so 0, -6, -3, 3, and -1. So the smallest is -6, then -3, then -1, then 0, then 3. Range, -5, -5, then -3, and -2, 4, and 7. And this one is a function, and it's because each input has exactly 1 output. That's actually all I'm going to cover on the front. The majority of what we're going to talk about is going to be on the back side. So go ahead and flip it over. So the sticky notes really are there to help you really focus in on what you're looking at. It's just a visual aid. Now, if you find that the sticky notes, like I mentioned the other day, if they don't actually help you, then you don't need them. So let's look at the domain. First, I'm going to start the first example, and maybe the first 2 examples. I'll use the sticky notes, and then I'm going to take them away and see if we can get to the domain and range without them. So when you are finding the domain, it's left to right. So when you place your sticky notes, you want it to go on the far left side of your graph. So, and I don't cover it up, but I just a little bit to the left of where my graph starts. And then we place it on the other side, on the right side. So here's where you can draw maybe some lines down to the x-axis, but we're looking at the possible x values. And it is really easy to get them confused. So I think that the sticky notes really help that visual part of it. So if you look at the x value here, remember that this is an ordered pair, and we can even write that ordered pair. That is actually 0, 4. So the x value, the smallest x value, is actually at 0. And I'm going to write that note. So smallest x value is at 0. And then I'm going to write the largest. So the largest x value is when x is 5. This ordered pair is 5, -1. So the largest x value is at 5. And since it's connected, we are looking at all of the x values in between. So the domain is, we use a compound inequality. 0 is on the left, 5 is on the right. We're talking about the x value, so you can put the x in the middle. And this is an and inequality, and it is including 0 and 5. So we're going to use less than or equal to symbols. So 0 is less than or equal to x, which is less than or equal to 5. Remember what I said the other day was you could also think about all of these points getting drawn to the x-axis and making a single number line. So your x-axis is your magnet, and all of these points are magnetized. So if they're all drawn to the x-axis, then it would form a single number line that looks like this, from 0 to 5, and we would be shading in between. Okay, so that's for the domain. The range, bottom, so I'm going to say smallest y, and then largest y. So the smallest y, we wrote that ordered pair, it's underneath my sticky note. That y value is -1. The largest y value, up top here, that ordered pair is 0, 4. The largest y value is 4. Y is in the middle, and we use less than or equal to symbols. Okay. So again, this is, if you haven't done this before, this is a little tricky to get to really get comfortable with, and it's not unusual for a lot of mistakes and a lot of confusion in the independent practice. So if that's something that you ultimately are experiencing, then I don't really want you to be concerned by it, because it just takes a little bit of time for us to fully process what's going on. Let's look at the next one. I'm going to use the sticky notes, and I'm going to place left to right. So smallest x value, look at the x-axis, that's at -2. Largest x value is at 2. And x is in the middle, and it's including. You know it's including because we have a solid dot, or solid point. Range for this one can be a little challenging because it's curved, but you're still fundamentally looking at the same thing. You're looking at the smallest y value. The smallest y value occurs at -3. Now it happens in two different spots, but it's still the smallest y value. So -3 is the smallest. The largest is up here at the top, or up here, cover everything else up, and that y value, that point is 0, 1. Largest y value is 1. And use less than or equal to symbols. So -3 to 1, inclusive of both of those numbers. If we're determining whether, I didn't answer the function part for the first one, but yes, this is a function because it passes the vertical line test. And the first one does as well, but I won't write that down. Let's look at 3. So hopefully you are getting a little more comfortable with this. And this time I'm not going to use the sticky notes. You can if you'd like to, but if you're using them, then go ahead and place them on either side, left and right. Now what's different about this one is that I have an open circle. And remember, in graphs, it doesn't matter if it's two-dimensional or one-dimensional. An open circle means that it's not inclusive of that value. So even though we have an open circle at -5, we're going to say that that's our minimum value. So our smallest x value is -5. But since it's not including -5, we just use a less than symbol. If that circle was filled, we would have less than or equal to. That's the only difference. And then on the right side, that x value is 5. Again, not inclusive because we have an open circle. Looking at the range, again, place your sticky notes if you want, down at the bottom and then up top. So the smallest y value going to the y-axis, that is -2, not including -2. We go all the way up to 2. So that's y. And it does matter what variable you use when we're talking about domain, unless it says otherwise. We're assuming that it's x, and for range, we're assuming that it's y. And it's also labeled in the graph. We have our x-axis and our y-axis. Okay, let's skip down to, let's do 5 and 7, and we'll call it good for the video. So 5. This one I am going to use my sticky note for because this graph looks really weird. But a weird graph doesn't mean that the domain is any more difficult to find. You can see that it's all connected. So there's no holes anywhere, and we have solid points. So if I put my sticky note on the far left side, that is the smallest x value is -5. And it's inclusive. The other one, other side, that is also a closed circle. So far right side, that x value is 1, +1. So my domain is from -5 to 1, including -5 and 1. Range, bottom of the graph, is actually right here. That value is at -1. Anything under the sticky note, my graph doesn't exist, but my graph starts to exist right here. That's the lowest point. So the range is -1, and then all the way up at the top, that y value is 5. This is not a function because it fails the vertical line test. So it fails the vertical line test at multiple spots, but one example would be right there. It's going to cross in this particular line 1, 2, 3 times. Last one we'll do is 7. So the domain, far left, using my sticky notes again. So I have something weird's going on here. I have at the far left, I have 2 different spots. And I have a closed circle and I have an open circle. So this closed circle trumps the open circle. So that means that -4 is actually inclusive. It is in my domain. Far right side, -2. Again, inclusive. There's no, you can assume that it is inclusive if you do not see a hole. And I don't see a hole. So that is -2. So from -4 to -2. The range, bottom of the graph, this confuses us sometimes. So I get a lot of students that will tell me that x value is, or sorry, that y value, the bottom value is in -4. That's because you're looking at the x. What is this ordered pair? This ordered pair is 1, 2, 3, -4, but the y value doesn't change. It's 0. And that's what we're looking at for the range. So the bottom value, the smallest y value, is 0. And we have a closed circle there, or a closed dot. The top, highest the graph gets, is at +4, but there's a hole there. So we use just the less than symbol. So 0 is less than or equal to y is less than 4. Not a function because it fails the vertical line test. Okay? All right, so when I check this, I expect to see 1, 2, 3, 5, and 7 done on this page, and then on the front page 1 and 2. Then you'll get full points. And then in addition, you're working on, this is for completion. I am going to purposefully not post the answer key to this because I don't want you guys to get overwhelmed if your answers are wrong. So we will go over any questions that you have next class period, which will be Monday. All right. Thank you.